Hello, so this is a video about the idea of excess and the limiting reagent in chemical reactions. So if we think about this simple equation here, we're reacting magnesium metal with hydrochloric acid to make magnesium chloride and hydrogen gas. And we'd quite like to know if I have a certain amount of each of these reagents. So if I've got 0.2 grams of one of them and that volume and concentration of the hydrochloric acid, it'd be quite useful to know which of these reagents is in excess, by which I mean that at the end of the reaction some of it would be left over, and which of them is the limiting reagent, by which I mean all of it would be used up. Okay. Now, why might we want to know that? Well, it'd be quite useful, say in this reaction, if we're making magnesium chloride, it'd be quite useful to know if all the hydrochloric acid has been used up, because that means then that the solution that we've made is no longer acidic. So that's one possibility. Another possibility is that we might have one of the reagents is very expensive and we want to make sure that all of that reagent gets used up, in which case we'd add an excess of the other reagent to try and make sure that all of that expensive reagent gets used up. Okay, so the calculation that I'm going to go through now is basically trying to decide which of these reagents is in excess, as in some of it's going to be left over, and which is the limiting reagent, as in it's all used up. Okay, so I've got myself a little grid here with the calculation sort of laid out, and you don't need to do this exactly like this, but you should follow these steps. So what I'm going to do is I've written down in the first, so I've got a column for magnesium and a column for hydrochloric acid. I've written down either the mass or the concentration of volume of what we have, and I'm going to use that to calculate the number of moles. So the two equations that I'm going to need to use to do that, just come over here, are number of moles is mass over gram formula mass, and number of moles is concentration times volume. Okay, so these are both equations that should be fairly familiar to you, but if they're not, go and have a check on them. This is what we're going to use if we're given the mass, and this is what we're going to use if we're given the concentration and volume. Okay, so coming back to actually doing that calculation, the first thing we're going to do is just work out how many moles that we have of the two reagents. So in the first one, for magnesium, we're given the mass, so we're going to use number of moles is the mass divided by the gram formula mass. Okay, and you would normally go and look in your data book, but for now, helpful post-it tells me that the gram formula mass of magnesium is 24.3 grams per mole. Okay, so we're going to just do that calculation. Number of moles is 0.20 grams divided by 24.3 grams per mole, and that gives me 0.0082 moles. Okay, and then moving over here, we're going to calculate the number of moles of the hydrochloric acid. Okay, so here we're given a concentration and a volume, so we're going to use the other equation. Number of moles is concentration times volume. And then we're just going to be careful because we're given the volume in centimeters cubed and the number and the concentration in moles per litre, and we just need to make sure that those units of volume match one another. So I'm just going to divide that number by 1,000 to get the volume in litres. Okay, so 100 centimetres cubed divided by 1,000 is 0.1 litres. Okay, and then I'm going to get the number of moles is my concentration, 0.1 moles per litre, multiplied by my volume, which is 0.1 litres. Okay, so my number of moles is 0.01 moles. Okay, now that's how many moles of each of the two reagents we have at the start of the reaction. Okay, now how do we use that to work out which one of them is the limiting reagent and which one of them is in excess? Okay, remember that's what we're doing. So what we will do is we'll start off by just reminding ourselves what the ratio of the two reactants is. Okay, so we've got what we know, going back to our equation, we've got 1 mole of magnesium reacts with 2 moles of hydrochloric acid. So all the time in this reaction, 1 mole of magnesium is reacting with 2 moles of hydrochloric acid. Okay, so we've calculated the number of moles we have, and now we're going to use the ratio to calculate the moles that we need of one of the reagents to react completely with the other one. Okay, so that's what I mean by the moles we need. So let me just explain that a little bit more carefully. So what we're going to do is we're going to pick one of the reagents, let's say the magnesium, and we're going to calculate how many moles of magnesium, how many moles of hydrochloric acid we need to react with all of that magnesium. Okay, so if we had 1 mole of magnesium, the answer would be easy because the equation tells us that we need 2 moles of hydrochloric acid. But that's also telling us that however many moles of magnesium we have, we just multiply it by 2 to get the number of moles of hydrochloric acid that react with it. Okay, so for every 0.0082 moles of magnesium, which is what we need, which is what we have, sorry, we need 0.0164 moles of hydrochloric acid. Okay, so that's just literally using the equation that says 1 mole of magnesium reacts with 2 moles of hydrochloric acid. Okay, and now we just have one final step, which is to compare the number of moles that we have with the number of moles that we need to react completely with the magnesium. Okay, and let's just think about that. We have less hydrochloric acid than we need. Okay, so there's much less hydrochloric acid in that volume and concentration than we need, and so what that's saying is we have much less than we need, so all of this is going to get used up. So that tells us that this is the limiting reagent, the hydrochloric acid, and this is in excess. Okay, so that's saying all of the hydrochloric acid is going to be used up, but some of the magnesium is going to be left over. It's in excess. Okay, so that's just how to do that calculation. And if you try and think about it in those steps where we've got the masses, concentrations and volumes. We calculate how many moles of each that we have, and then we use the ratio from the chemical equation to work out how many moles of this that we need to react with this, and then compare the two to decide which one's the limiting reagent and which one's in excess. Then really you can't go wrong. So that's that. Now, just something to think about. There's a few questions here that could be asked as kind of extensions to this. That's not the only kind of thing that could be really checked. So how could we experimentally verify that all the hydrochloric acid has been used up in the reaction? Okay, so we did that calculation, but is there any quick check that we could do if we were reacting magnesium with hydrochloric acid just to check that all the hydrochloric acid's been used up? Okay. How can we calculate the number of moles of magnesium chloride that we've made? Okay, so that's something to go and think about. How can we calculate the mass of magnesium left over? And how can we calculate the volume of hydrogen produced at room temperature and atmospheric pressure in this reaction? Okay, so 4 questions to think about based on what we've talked about today, but that's deciding which of 2 reagents is the limiting reagent and which one is in excess. Okay, thank you.